Boys and girls, tell me what to write. And don't say it faster than I can write it, okay? All right.
30, 50, 20, 50, 70, 90, 20.
Okay. Gosh, I hope that's not how your singing goes tonight.
Nope.
People saying words at different times. Okay. So the next thing I want to do is the application problem. I'm looking at this and it looks to me like a 4th grade problem. Now I'm going to tell you something that you need to know, so pay attention. When you're solving a problem on your problem set or your exit ticket, you really need to do the RDW. And when I have an area problem, the best thing to draw is what, boys and girls? A rectangle. It says the area of a rectangle. So go ahead and draw that now. Rustin, what's the formula for area that you learned in 4th grade? Cooper? I'm writing it. Does this ring a bell to you?
Length times width equals area.
Length times width equals area. Okay? And we're going to plug numbers into this formula. Starting next year, you're going to do the same thing, so we might as well do it now. Just a minute, okay? It says the area of a rectangular vegetable garden is 200 feet squared. The width is 10 feet. What is the length of the vegetable garden? So on this rectangle, let's write down what we know. What do we know? We know the area, don't we? So write that in the middle. What else do we know, Cooper?
The width is 10.
The width is 10. We do not know the length, do we? So if I'm going to plug my numbers in to the formula, I'm going to do length times 10 equals what? 200. I don't know the length. Now, how do you solve a problem like this, Brian?
200 divided by 10.
You're right. And that looks a little bit familiar, kind of like our sprint we just did. So how many zeros can I cross off?
1.
So my answer would be 20 what?
20 feet.
20 feet. Now,
Square.
let's talk, not squared. The only one squared is area.
Oh.
Okay, let's talk about what really happens to 200 when I divide it by 10. Who knows? Katie?
You take away a 0 because if you multiply anything from 10 you get 0.
Okay, so that's true. Anything times 10 add a 0 to the end, so it makes sense to take off a 0 when you divide, because multiply and divide are opposites. Okay? What else do we know about what happens to the number 200? Think about the place value chart. What happens to the number 200 when I divide by 10? What? It moves over. Moves over to the right, doesn't it? Okay? What happens to my decimal? Well, with the trick, we hop the decimal to the left, don't we?
And it erases the 0.
So that's the reason why I can cross off a 0. Because the digits are moving, and you don't need those zeros anymore. Okay? That's pretty much going to be our lesson today. Let's look at the first one. Now, I was watching Dwayne on his recording, and he said that students need to briefly review what they did in 4th grade when dividing by powers of 10. And then you can go ahead and use the trick. Well, we already know the trick, don't we? Cross off the number of zeros you have in your divisor, and then divide. So what does it look like with place value discs? Anybody remember? Has something to do with circles and arrows. Turn the paper over if you haven't yet.
Angles?
And from 4th grade, okay? So if I'm going to show 420 on the place value chart, 400s, and I don't know how you do it, but I figured out one day that if I write the number before I make the zero, the number always fits in my zero, or my number always fits in my circle. Okay? So now, did you do that? Okay, and how many 10s do you need? Okay, and when I divide by 10, how many place values do the digits move over? 1. So I'm going to start with my 10s. Divide my 10s. What do I get? 2 1s instead of 2 10s. Then I will divide my hundreds by 10. And what do I get? 4 10s. Kind of hard to see, isn't it? But it's everything that's not crossed off. So my answer is 4 10s and 2 1s. And does that make sense using our little cross off the zero trick? Totally, okay? Did this seem more complicated last year than it does now?
Yes.
You're much better with numbers, aren't you? Okay, let's do the next one. The next one, how's this problem different? Right, mine didn't save. Yours is correct, isn't it? So this should be thousands, hundreds, 10s, 1s. I did fix it, but I bet I opened it too soon and it didn't save. Okay, so how do I show this problem on a place value chart? How many thousands do I have? 1. How many hundreds do I have? Uh-oh, I made a mistake.
What'd you do?
I think I better write my number first, don't you?
Yeah.
Yeah. And maybe squeeze them together a little more. So how many hundreds do I need? 6 of them. Now what happens to the digits, Jaden, when I divide by 100?
They move. They move twice.
They move twice. And we learned in Module 1 that they move twice. We can remember that by counting the zeros, or 10 to the what power? Second. So we can look at the exponent too, can't we? So that 1,000 becomes 110. And the hundreds
So now it's 46.
will move over to what place value?
1s.
The 1s. And your place value chart looks much better than mine. Mine's wrong. So, this is a quick review of 4th grade and what division looks like. So I have 110 and how many 1s? 6. And that's what it looks like on a place value chart. Okay? Now those are the only 2 we're going to review. You will do 2 on your problem set. And I'm not sure if the exit ticket asks for place value discs or not. But all we're doing, you know what we're doing, don't you? Refreshing your memory. What really does happen, and why do I get to cross off those zeros? Okay? Take a look at the next problem. It's a little bit different. I know. So how is this problem a little bit different, Robert? And don't say the numbers are larger, because it's more than that. What am I dividing by? How's that different from 100?
It has something.
other than a 1, right? Now those numbers that we just worked with, they're called powers of 10. You know that, don't you? 10, 100, 1,000, 10,000. This one is not a power of 10, but we're going to break it apart and pull out a power of 10. What power of 10 can I take out of 600?
6.
The 100 and a 6. Good. And then go ahead and rewrite the problem. We did it like this a few days ago. Do you remember that?
Oh, yeah.
We did. We had 2 little division signs sticking out there. Looked odd, didn't it? Okay. And no, you don't have to draw your arrows. That's there just to remind you to break it apart. What property is this where we break a number apart? Distributive. Very good. Very good. Okay, so the easiest way to do this is get rid of your zeros first. So I'm going to divide 24,000 by 100. In 5th grade, here's what I do. I cross off my zeros. Do I want you to cross off your zeros? Yes. And the reason is because you need to be able to write what's left over on the second equal sign. What is left over, boys and girls? 240 divided by
6.
Now, how do I figure this out?
24.56.
And then add a, okay, good. So 6 times something equals 24. 4. Add your 0 and what's your answer? 40. Okay, let's do another. Okay, this one's larger numbers, but I think we can handle it. Okay, so what power of 10 can I take out of 9,000? 1,000, or 10 to the 3rd. Very good. And that leaves a what? A 9. Whoops. So how many equal signs, boys and girls?
3.
So you know what I mean by when you don't know what to do, just put 3 equal signs down or a tape diagram, and you're going to be right most of the time, aren't you? Yeah. That'll get you started. So get rid of your zeros first. What does that leave?
180.
180 divided by, okay, 18 divided by 9 equals 2. Add your 0.
20.
Okay. All right, that's your lesson today. I'm just going to put